Hello and welcome. We're glad you have joined us. My name is Amit Neom. I'm a Microsoft technical trainer specializing in security and AI. I am here to walk you through the AZ-305 course, Design Infrastructure Solutions. In this session, we design a data storage solution for relational data. What happens when your database needs to grow fast without downtime and security cannot be optional? In this module, we'll learn how to design and recommend the right data solution for relational data, from Azure SQL DB to Cosmos DB and table storage. We'll plan for scalability, high availability, and protection of data at rest, in transit, and in use. By the end of this session, we will be able to identify the best fit for our workloads based on performance, security, and growth needs. So let's get started. First, we understand what type of data is that and what does the app need from it. Because the storage service should match the data shape and the access pattern. Structured data have a shared schema, relationship, classic relational data. Semi-structure is flexible structure or schema like JSON, XML, still queryable but not always relational. Unstructured refer to images, videos, no structure, no relationship. We will focus on structured and semi-structured data. If our data is relational, which Azure SQL option fit responsibility and compatibility needs? Let's discover the design for Azure SQL databases. Azure SQL Service offers both infrastructure and platform-based deployments. We want to consider how much control do we need? How much do we want to manage? How big is our database? What app are we building? What are the availability metrics? Any other security or technical requirements that we have? We can work with SQL VMs. Those provide us 100% compatibility and control. Those are best for lift and shift, migration for application requiring OS-level access. We can modernize our workloads and migrate into SQL managed instance. This is a platform-native scenario, allowing us VNet integration. It is great for most lift and shift operation where we want compatibility without virtual machine management. We can go for the most flexible solution, platform managed SQL databases as a service. This provides us a fully managed platform database, massively scalable and highly available, which will be best for modern cloud application with fast provisioning, flexible scaling, speed, agility, and strong management capabilities. Both SQL databases and SQL managed instances are optimized to minimize overall management costs for managing multiple databases in a pool. To recommend a solution for database scalability, we need to evaluate the available options. Do you have to manage and scale multiple Azure SQL databases that have varying and predictable resource requirements? You can choose Azure SQL Elastic Pools. Are you developing a new application with a single database that you want to test before launching it to thousands of users? You can choose Azure SQL databases or managed instances. Do you need to optimize the price and performance for a group of databases within prescribed budget while delivering performance and elasticity for each and every database? You can choose Elastic Pools. Those provide us cost predictability and shared capacity. Single database scaling gives us simplicity and clear performance tuning. Your application SLA is basically the product of your weakest dependency. Databases are often that dependency. Let's learn how to recommend a solution for database availability. We can choose between three options for our pricing model. We can go for data transaction units. This is a bundle of CPU, memory, IOPS into one measure, simpler sizing. We can go for vCore. That gives us transparency and independent scaling for compute and storage. We have a serverless tier that automatically scales compute and can pause. Be mindful of resume delay. Provisioned compute is best for databases with more regular, predictable usage pattern and high average compute utilization over time. Serverless compute is great for unpredictable usage pattern with lower average compute utilization over time. Serverless is like a motion sensor for lights. It is cost-saving when the room is empty half of the day. To match to our availability requirements, we can choose between different tiers. For example, general purpose or standard tier. This is a balanced tier for typical applications that need reliability but not extreme I/O performance. We will work with one primary replica, platform-managed availability architecture, and backups using redundant storage. Higher availability can be provided with a business-critical or premium tier. Those are optimized for high transaction rates and low latency for online transaction processing applications, performance, and highest resiliency. High availability is achieved by replicating both compute and storage to additional nodes. 3 replicas, 1 read scale-out with super-fast local SSD storage. This is a great fit for payment, checkout, system where latency and fast failover matter. The highest availability and actually cost-effectiveness can be achieved with a hyperscale tier. This is built for very large online transaction processing databases and fast recovery, allowing us to store up to 128 TB in size. This service tier has a unique architecture because it uses a tiered layer of cache and page servers to expand the ability to quickly access database pages without having to access to the data file directly. It provides separate scaling of storage and compute, multiple replicas, up to 4 read scale-out, snapshot-based backup, fast restore in minutes instead of days. We better plan our failover strategy. We can choose to do it within one region or across regions. In the same region, we can use always-on availability groups with failover to the secondary replica. Across regions, we use geo-replication with failover groups. Active geo-replication is configured per database and uses asynchronous replication, so disaster recovery can involve some RPO trade-offs. And if you need a stable endpoint for groups of databases, look at failover groups. Let's do some activity. If we need a highly available Azure SQL database that is over 40 TB in size, what do we choose? We can go for hyperscale. If we have an on-premises SQL migration to Azure, what will we do? We can use Azure SQL databases or SQL VMs. If we have a known database usage that we would like to consume in minimal costs, we can use the DTU pricing. If we need to replicate across regions, we can use geo-replication with auto failover groups. Say we have a cloud platform that tracks car dealership inventory. For that, we can use elastic pools. It is likely for each dealership to have their own stored database. This scenario would mostly benefit from elastic pools. Now, design security for data at rest, data in transit, and data in use. We will take a layered approach for our defense. From the network perspective, we would like to consider our perimeter with built-in firewall and networking rules. We can consume service endpoints, private endpoints to make sure that all traffic is coming only from our private network. From identity and access perspective, we can consume authentication from Entra ID, allow access granularly with role-based access control. For data protection, we can discuss about encryption at rest, transparent data encryption, encryption in transit, TLS, and encryption in use, always encrypted. There are some other features that will help us mask sensitive data. For security management, we can use Microsoft Defender for Cloud for ongoing vulnerability assessment and active threat protection. To govern sensitive data, we can bring Purview. The impact is clear: reduced blast radius, better compliance, and safer operations. Start with identity, because identity is the new perimeter. Azure SQL supports SQL authentication as well as Microsoft Entra authentication. That allows to centralize the identities in Entra, including the credential rotation. You map the Entra ID identities to database users and manage access with roles and permissions granularly. That will provide us with simpler governance, stronger security posture, and better auditing availability. When the requirement is global scale, low latency, flexible models, we design for Azure Cosmos DB. Azure Cosmos DB is a fully managed, globally distributed database built for modern, cloud-native application that needs single-digit millisecond response time and guaranteed performance at global scale. It is commonly used for web and mobile apps handling user-generated content. It is used for retail and marketing systems that rely on event-driven data. It is very popular in gaming workloads with massive traffic spikes. It can also be used for IoT scenarios where data ingested continuously and queried in near real time. Let's see a deployment of a multi-region web application with Cosmos DB replication. Authentication is enabled with Microsoft Entra ID. Then Azure Front Door routes to active region or failover into a standby region. App Service hosts the website and the RESTful web APIs. Tasks from the web app are queued in an Azure Queue storage. Queued messages trigger the function app to pull them. Azure Managed Redis caches the database data for the function for low latency. Azure Cosmos DB uses geo-replication to all operational regions. Azure Storage Tables and Azure Cosmos DB Tables are two key attributes stored with different capability levels. Azure Table Storage is a simple, schemaless, key-value style storage. Cosmos DB Table API is a table-compatible API plus premium features such as scalability, availability, and high throughput. We can start with table storage for cost or simplicity, then move into Cosmos Table API when we need premium or global behavior. Let's see an example of minimal storage, change feed to replicate data. A user authenticates with a Microsoft Entra ID. Azure Front Door switches the user traffic to the standby region if there is a regional outage. App Service hosts website and RESTful APIs. The web app delegates responsibility to code hosted by functions to handle the background tasks. The tasks are queued in the Azure Queue storage. Queued messages are triggering function app, which perform the background tasks. Azure Managed Redis caches the database data for the function to speed up the function apps and the web apps. Azure Cosmos DB holds recently generated data. It is also issuing the change feed that can be used to replicate changes. A function app reads the change feed and replicates the changes to Azure Table Storage. Another function periodically removes expired data from the Azure Cosmos DB. The table storage provides low-cost storage. Based on our workloads, we must choose the API that fits to the requirement for a new or existing application. Cosmos DB let you modernize without forcing your team to learn new database language. We can choose Cassandra DB, MongoDB, PostgreSQL, or table storage, all applicable within the same Cosmos DB with different APIs, so we can keep the data in its raw native format. Now, let's review what we learned. Let's choose the service based on the scenario. If we need a globally distributed, multimodal database with support for NoSQL choices, we can choose Cosmos DB. If we need a fully managed, scalable MySQL relational database that has high availability and security built in with no extra cost, we can choose Azure Database for MySQL. If you need a fully managed relational database that provisions quickly, scales on the fly, and includes built-in intelligence and security, go for Azure SQL Database. If you need to host enterprise SQL Server application in the cloud and have full control over the server operating system, that's SQL VMs. We have a decision tree to help us make the right choices. Time for a use case. This time, Tailwind is looking to move their existing public database website into Azure, as the website front end is also being moved into Azure. The website front end will initially be deployed in 2 regions for redundancy. However, it is expected that as the traffic increases, the website will be replicated to other regions around the world. Our database holds the product catalog for all online orders. Currently, the database runs on a single Microsoft SQL server with always-on availability groups on premises. Our primary concerns are high availability. Any outages may result in lost sales or customer confidence. Website performance. Browsing or searching pages with many items is being reported as being sluggish. Security. We're very concerned about personal or financial information stored in the database being exposed. So we need to design a database solution, include authorization, authentication, pricing, performance, and high availability. Think, how are we incorporating the well-architected framework pillars to produce high-quality, stable, and efficient cloud architecture? Let's see an example solution. We will first define the primary region. We can use Azure SQL Database with the Business Critical tier. We will define the secondary region with geo-replication from the primary region. We can optimize the latency with Azure Managed Redis. We will secure the access with Entra ID authentication and Azure Front Door. We will protect with a Microsoft Defender for Cloud. In this session, we have covered design for data storage, design for Azure SQL databases, recommend a solution for database scalability, recommend a solution for database availability, design security for data at rest, data in transmission, and data in use, design for Azure Cosmos DB and tables. This concludes our session. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topics on Microsoft Learn at aka.ms/learn. I'm Amit Neal. Happy learning!